Guys still busy with the quiz?
2 more questions.
Okay. And who else haven't I spoken to yet? Sabika? Is this like another Sabika? There's Sabika's iPhone, that is Sabika.
No, I changed my name.
Oh, okay. So it was Sabika's iPhone, now your name is Sabika.
Yes.
Okay. Let's go to the home phase. Okay. So we get, Kai, are you still busy?
I'm done.
Okay. So let's start the quiz. So the nice thing with these quizzes is that it's very interactive, as you guys can see. So you can see we made quizzes for grade 9 now. So these equations look easy to you guys, obviously. But you can remember when you were in grade 9 that it wasn't so easy, right? So that's why the grade 9s have these types of questions. Okay. Yeah, so let's start the quiz. So let's go. Okay. So can you guys all see the screen and you can hear me, right?
Yeah.
Okay, so the defining feature of arithmetic sequence is constant first difference, right?
Yes.
Okay, you're always adding or you're subtracting the same thing. The second difference of a quadratic sequence, 2a. Okay, it's 2a. And what is the first? What is the first difference equal to? The first difference. 3a plus b. Then it's 5a plus b. Then 7a plus b. Okay, right? Okay. The defining feature of a geometric sequence, constant ratio. You're either multiplying or you're dividing. The fifth term of an arithmetic sequence, okay, so is a plus 4dy, because the general formula is a plus dn minus 1. So if you sub in 5, so it's going to be a plus 4d, okay. So and look here, imagine I got that wrong, right? So you click on the do you guys see this light bulb? Do you guys see the light bulb?
Yeah.
So if you click on the light bulb, then it shows you where you must go to understand this question that you got wrong. Okay, so that's the nice thing. So if you guys get anything wrong, then you can easily just go back to the concept video and learn that part again. The third term of geometric sequence is AR squared, because it's AR to the n minus 1, so you're subbing in 3. Okay, in a sequence, if I say T4 is equal to 5, it means that the fourth term equals 5. Okay, because you're subbing in 4, so it's the fourth term, and the value of the fourth term is 5. Okay, great. And the second term of quadratic sequence, what is this one? What must you do? Anyone?
Substitute 2 into n.
You sub 2 into n, right? Because it's a, actually, you know, I can actually do that. Okay, do you guys agree it's an squared plus bn plus c, right? For the quadratic sequence, an squared plus bn plus c. So if you sub in 2 for n, which is the second term, then it's just going to be 4a plus 2b plus c. Okay. Which of the following is false? R equals 4, because it's an arithmetic series. Okay. And it's divergent, it's getting bigger. Okay. In the arithmetic sequence, which of the following statements is true?
The third one. No, not the
First
third
one.
The first one.
Why? Why is it?
Because it's a constant difference.
It's a constant difference, right? So therefore the consecutive terms, if you subtract consecutive terms, you'll get the same answer. Okay, great. And number 10, how can you prove a geometric series is convergent? is if?
Third one.
It's the third one because
-1 and 1.
R is a fraction. Whenever you multiply by a fraction, what happens to the number? When you multiply by a fraction, it becomes smaller and smaller and smaller, okay? Which is why it converges, because the numbers that you're adding become smaller and smaller and smaller. So imagine you got that wrong, right? So you could go back to the concept video on that and you can understand it. So that's the cool thing, right? Expand the series given in sigma notation above. Okay. Which one? What's the first term?
9.
How did you know it was 9?
You substitute 2 into k.
So this k equals 2 is the first term. So you sub 2 into there, and that's going to be 3 times 2 plus 3, which is 9. How many terms in this sequence, by the way? How would you know how many terms there are?
4.
5 minus 2 plus 1. Okay. And then the last term, which is going to be, you sub in 5. So it's 3 times 5, which is 15, plus 3, which is 18. So therefore, it has to be this one. Okay. Okay. Did you guys get this one? So for those of you who haven't done this one before. Kai, what did you say for this one?
I just guessed. I chose divergent.
Okay, it's right. Okay, but you understand why it's divergent? Anybody? Why?
I have no idea.
Does anybody remember the explanation I gave last time? Does anyone? Doesn't this look like it's
when it,
yeah?
Wait.
when it divergent, it gets bigger and bigger or smaller, something like that. I forgot.
Okay, but what's the difference between a divergent and a convergent series? What's the characteristic feature of a divergent series? Hello? What's the characteristic feature of a divergent series? Like, what's the difference between a divergent series and a convergent series? Hello? Can you guys hear me?
One of them, don't they refer to like a series that is like doesn't end, the infinity, something like that?
Okay, so let's go back to the drawing board. Okay, let's go back to the drawing board. So if I gave you a sequence 1, 2, 4, 8, is this convergent or divergent?
Divergent.
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 Okay, most of you said divergent, right? Because do you guys agree the numbers are getting bigger and bigger and bigger? Do you guys agree?
Isn't convergent like it's between -1 and 1, or?
Yes, but what does that imply? It means then it's going to do something like that.
Yes.
Because the numbers that you're adding are becoming smaller and smaller and smaller. So therefore, when you're adding very, very small numbers, it's not going to make much of a difference. So we say it converges. But here, you're adding bigger and bigger and bigger and bigger. So this goes to infinity. Okay? Do you guys see that?
Yeah.
Okay. But now, in this question, it asks you 1 plus a half plus a third plus a quarter plus a fifth. So what does this look like to you? What type of sequence does it look like?
So
It looks like it's getting smaller, right? Do you guys agree?
Yes.
But it's actually not. And this is the funny thing about this sequence. It's called the harmonic sequence, and you guys can read about it if you in your own time. The harmonic series is basically a series that it's named after the piano, I think. But basically, the way you can prove this is if you, and I don't want to spend too much time with the proof, but just for those of you who are interested, we said a convergence series gets smaller and smaller and smaller, right? You guys agree? You guys agree? It gets smaller and smaller and smaller. What is a half plus a third? Plus a quarter? Okay, ooh, that's a bit of a tough one to add, but like it's 0.5 and
1.08.
yeah, so do you agree it's more than 1?
Yeah.
So that's like saying 1 plus 0.8, and then if you keep on adding, the numbers become 1 point something. Do you see? It's getting bigger, but very slowly.
Oh.
Do you guys see that? It's actually not smaller, it's slightly bigger. It's only slightly bigger. Do you guys see that?
Yeah.
Add a third plus a quarter plus a fifth plus a sixth. What's that answer? Someone's mic is a bit loud. Just if you can mute the mic if it's a bit loud. Yeah. Who's gonna do a third plus a quarter plus a fifth plus a sixth?
It's like 0.95.
Okay, and if you add a seventh, it's gonna be
1.09.
1.09. So do you guys see? It's getting bigger, but very slowly. Okay, so that's why we say this is a very slowly divergent series. Very slowly divergent series, but it's not convergent. Why? Because the numbers are getting bigger. Do you guys see that? They're getting bigger, but very slowly. Okay.
Wait, so
But
this is divergent or convergent?
This would be the divergent, because the numbers are getting bigger.
Okay.
So that's why it was a bonus question, but you won't be asked this in your exams. Hopefully, I don't think, you shouldn't be asked this in your exam, but I just thought it would be nice as an application. Okay. The next thing I want to do quickly, okay, before we start, is just go through the algorithm. Did you guys manage to watch the video that I made?
To try it.
Did you guys manage to watch this video, the algorithm video? I know all of you didn't watch it because of the number of views. So maybe I should just quickly go over it again. So basically, you guys, for those of you who are new, others will tell you that Tutonic, we follow a particular algorithm for students that is heavily weighted towards understanding concepts. And you'll see that we have concept videos on pretty much actually everything, to be honest. Every section in the syllabus from grade 8 to grade 12 that you can watch to learn your entire syllabus. And this is the section mind map, so you could even go back. So this is functions. So if you wanted to go back to grade 10 functions, you can, grade 9 functions. And for the simple reason that maths is a spiral curriculum. And what does that mean? It means that what you learn in grade 9, 10, 11, and 12 is built upon in grade 10 and 11 and 12. You are basically going to use in grade 12. So what you guys must realize is that maths is a marathon that starts in grade 8 and it ends in grade 12. Okay? Now, unfortunately, most students from grade 8 to grade 11, they walk the marathon. And then in grade 12, they start sprinting, you see. Now, the problem is that because they only started running in grade 12, there's so much to catch up. Do you guys see?
Yeah.
right? Now, I'm not saying that it's too much to catch up. All I'm saying is there is stuff to catch. But the nice thing with Tutonic is that we make that catching up process easier for you, because we've taken all the sections like algebra, number patterns, and we allow you to start from the beginning and go and rebuild your foundation. So maybe you don't understand what is the gradient. Like, these people are using gradient. Like, what is gradient even? Like, what is an intercept? What is domain and range? What is an exponential function? What are these guys talking about? What is a trigonometric function? This is a cool video making sense of trig functions using circles for those of you who want to understand why the sine function looks like it does. Like you know, you guys know how the sine function looks, right? That wave, right? But have you ever wondered why it looks like that?
Yeah, I just thought it was just like that.
Oh, no, it's not just like that. So why does sine start at 0 and cos start at 1, right? So all these fascinating questions of maths we talk about in the concept video, making sense of trig functions using circles. So I show you how to use circles too. So this, Tutonic is not just about learning maths. We actually want you to enjoy maths. And I believe if you understand the maths, you begin to enjoy it. And if you enjoy the maths, you work harder. And if you work harder, you tend to do better in terms of the marks. So if you look at the algorithm, you'll see that I say that everything should start with the concept videos. Everything starts with the concept videos. But after you've watched the concept video, you take the concept quiz. So like the number patterns quiz that you guys did now, right? But look at what I say here. If you did not obtain full marks for the quiz, then revisit the concept videos to close your gaps, okay? Notice how I don't say practice questions. For practicing questions, I say once you obtain full marks for the quiz. And this, for me, is the mistake that students make the most, is that I'm not saying that students don't practice past papers. Many students have hundreds of past papers. But the problem is when they do the past papers. Many students start over here, but they neglect this and they neglect this. Because what we realize is that when it comes to mathematics, these questions are based on this. So if this is not strong, there's no use in doing this. So that's why I always feel sad for students who do so many past papers, but the past papers are not going to benefit because these are not strong. But how do you know what is strong? How do you know when your understanding is strong? You know your understanding is strong when you get full marks for this, because the concept quiz tests this. Okay, so do you guys understand now?
Yeah.
Okay, so that's why before you do a past paper, I would actually just do the concept quiz first to check, okay, listen, do I remember all this stuff? Before I do the past paper, do I actually remember all this stuff? Okay, right. And then only start with questions. So do you guys see it's a process? Then only start with questions. Once you've got full marks for the quiz, then you start with the questions. And you can take questions from school, or you can take questions from the Tutonic Bank. Now, Kai, I know you just joined, but I don't know if have you seen the Tutonic Bank yet?
The PDF with the globes.
That's the concept map. That's the concept map. But Tutonic also has a Tutonic Bank, which has past questions that we've received on different sections with the video solution next to it. So you can practice different questions with the video solution. And there's over 400 of these questions from the entire syllabus. So that's why I really recommend that you guys practice questions from the bank, because the nice thing with the bank is that you've got the solution next to it. It has tutor explanations. And you can also practice your own questions from school. But what you guys will realize is when you practice the questions, after you've got full marks for the quiz, you'll start to realize that you're getting a lot more of these questions correct, because this is strong. Okay? And then after you've practiced the questions, then then you come to the tutors. Okay, then you go ask a tutor. You don't start here. Okay, guys? You don't start here. You don't start here. There's a process. Okay, you start here. And it's not because we don't want to answer your questions. It's because we believe that if you follow this methodology, it's in your best interests. Okay? Because what you'll realize is that this will answer most of your questions, actually. If you follow this approach, most of your questions will already be answered. Okay. And then I've got a nice quote here from the end. Those of you who were here last week might remember we spoke about that. So does everybody understand the algorithm now?
Yeah.
Does the algorithm
Yeah.
make sense? Does the algorithm make sense?
Yeah.
Yes, it does.
Are you going to do the algorithm? Are we going to follow the algorithm?
Yes.
Okay. For all the sections. Okay. For all the sections. And when I say concept videos, I don't just mean grade 12, right? I don't just mean grade 12. Why? Because everything you learn in grade 12 is based upon what you've done in grade 8, 9, 10, and 11. So before you even start with this, you must do this, just to make sure that you fully understand. Okay? So that could mean taking the quizzes for the previous grades, but maybe just watch the concept videos. Anyway, let's start. Okay? So you guys understand now? Am I clear about what I expect from all of you?
Yes, sir.
Okay? Does it make sense? Because if you understand, then that's the most, like, if you understand that this approach that I'm giving you is, for me, if you follow this approach, you will succeed. I can guarantee for all of you, if you follow this approach strictly, all of you will improve your maths marks. You will start to enjoy maths. And I can see a lot of you are actually doing this. A lot of you are in this live session right now are doing this, and they're following this approach. And I can see that the benefit that it's having on those students. But I want all of you guys to do that, okay? So let's start. So Kaylee's, I'm gonna do Kaylee's question afterwards. Okay, so let's do, okay, so Patego isn't here. Okay, but it's fine, I can ask the others. Okay, so let's start. So, okay. Right. So it says in the figure, TRSW is a cyclic quadrilateral. Now, remember guys, I always tell you, before you look at the questions, you already have answers. Before you look at the questions, you already have answers. Now tell me, what do you guys know? What are the 3 properties of a cyclic quad? Quickly.
Opposite angles are supplementary.
Right? Opposite angles are supplementary. What else?
The exterior angle is equal to the opposite interior.
Right. And then the third one?
Angles in the same segment.
Yeah, angles in the same segment. Now, what you'll notice is that these properties that I'm asking for you right now is exactly what's over here. Do you guys see that? So I want you guys to memorize this. Memorize the properties of the cyclic quad. And obviously understand it, but also memorize it so that it becomes quick. It becomes automatic, okay? And then here are the 3 properties of the tangent. You see how beautifully it's laid out, right? So there's 3 properties of tangent, 3 properties of the cyclic quad, and then 3 fundamental circle properties, okay? So I want you guys to really memorize it, say it over and over again so that it becomes almost automatic, okay? Right, so because this is a cyclic quad, we can apply cyclic quad theorems. Do you guys agree to this, this shape? Yeah. So here's the cyclic quad. Here's the cyclic quad. Right. So what is T1 equal to?
T1 is equal to S1.
S1.
It's equal to S1. Do you guys agree? Do you see it? Exterior angle equals the opposite interior angle. Okay. So just from them telling me this is a cyclic quad, I can really fill this out. And of course, T2 is just 180 minus. We don't really have angles in the same segment yet, but they do tell me that TW equals WS. So TW over here equals WS. Why do you think that's significant? What can you deduce from there?
The triangles are congruent.
Can you deduce congruency from just having one?
Can't you say the equal chords, equal angles?
Equal chords subtend equal angles. So
Yes.
you just put the word subtend there. So it's not congruent. It's not necessarily congruent, and I'll prove it to you why it's not necessarily congruent, because you only have one side, right, and one angle. That doesn't mean that it's going to be congruent. Okay. And of course the angle must be inclusive. Okay. So Sabiha mentioned that equal chords subtend equal angles, right? So therefore, if this is 30, what else is going to be 30?
R3.
R3.
R3. Okay, great. So do you guys see from this to 5 words here, we have all this information already. RT and RS are tangents. Okay, there, keyword, guys. Keyword. Tangent. BWZ. What are the 3 properties of the tangent?
Shaded at a perpendicular to center.
Yeah. Yeah. You can just read it for me.
Oh, the tan chord theorem, and then 2 tangents drawn to a circle from the same point.
Are equal.
Oh, equal.
Yeah. Okay. So I want you guys to memorize these theorems, okay? And understand them. Memorize them and understand them. So when you read the word tangent, automatically in your brain, you think the 3. Okay, that's the level that I want us to be at. When we read tangent, we think of those 3 things. When we read cyclic quad, we think of these 3 things. Okay, great. So because this is a tangent, can we apply, which tangent law can we apply to this question? Which one do you think?
Tanko theorem.
Right, so what is VW4 equal to? Uh,
30 degrees.
do you guys all agree? Okay, do you guys see there? Okay, if any of you are still not sure about Tanko's theorem, these are videos, by the way. What I'm showing you here are videos, like they're links to videos. So if you, like, I'm telling you to memorize this, but obviously if you click on one of these dots, it will take you to the video, right? So if you guys want to understand the concept, you can click on the video, but I'm just telling you that when you read the word tangent, you should memorize those 3 theorems. So therefore W4 is green, right? What about W1?
Also 30.
Because of R3. Okay. Right. And you actually know these angles. Do you agree? You know these? You don't actually have to do colors, but the colors help. The colors help. Okay. And if you really want to, you could maybe say that, you know, this yellow, we could make this yellow, and then this is yellow. Do you guys agree? Exterior angle of a cyclic chord.
Yeah.
You guys see that? Okay. So do you see here, Kai, that, I'm not sure who said, but you see why it's not congruent?
Yeah.
Because you see here's yellow, here's blue. Different angles. Okay. So, And okay, and then we've got another tangent, P or Q. Wow. Okay, P or Q is another tangent. So who wants to, can somebody else besides Hamza and Akhlaq, Nafisa, do you want to try telling me about this tangent over here? What can we deduce?
W2 would be 50 degrees because
W2 would be, yes, 100%. So maybe we can make, what color do you want to make this? I mean, we can have to do color. Okay, we can make it black here. Okay, 50 degrees, and that's 50 degrees. Yeah. Okay. And
then R1 we could work out by adding all the angles and saying 180 minus all those angles because of angles on a straight line, and then you say W3 is equal to R1.
yeah, so we can choose another color. We're running out of colors here. Orange. Okay. Okay. So, you know, we could even just replace all these colors with the numbers. But anyway, but do you guys see how we haven't looked at any questions yet? Do you guys see that?
Yeah.
We haven't looked at the question. Like, we've just read 2 sentences. 1, 2, 3 sentences. And we've already filled out the entire the entire thing. Do you guys see that? So this is what I want you guys to always do. Before you guys look at the questions, I want you guys to first fill out as much information as you can. Why is R3 30? We said this, right? You guys see equal cos obtain equal angles. So that's done. That's done. 2 other angles equal to 30. What else is going to be 30? We said there. Those 2 over here. Do you guys see that? Okay. And we said that's because of Tanko's theorem. Okay. So we just steamrolling through these questions here, right? Determine with reasons the size of S2. Okay. Now they want the size of S2. Okay. So we could work out S2. Do you guys agree we could actually just work out all these angles? So this could be 30. That's going to be 70, right? 100, yeah. Then this is going to be 70. Therefore, this is going to be 80, right? That's going to be 100. That's going to be 100. That's going to be 80. That's going to be 30. That's going to be, this is going to be 50, right? Because the black is 50. And that's going to be 30. Do you see we have the entire triangle here? 50. Right? You guys see that? How cool is that, eh? Like, how cool is that? We've done the whole triangle, done the whole circle. Okay. So S2 is going to be 80 because it's exterior angles of the cyclic quad, and you could have worked out that. Okay. And V, what's V? Where's V? 50. Okay. Is everybody comfortable with how we've come up with these variables, these numbers?
Yeah.
Yeah.
Okay. Great. Great. Okay. Now it says prove that WR squared equals this, RV times RS. What automatically pops into your mind here? What pops into your mind?
Proportionality theorem.
Proportionality, right? Now, just a reminder to you guys that Tutonic has made concept videos on proportionality for grade 12. There are 5 videos that Layla has made, very well made, I must say, and you have to watch them, right? Because remember I said, before you answer the questions, you start with the concept videos and then you do the quiz. Okay, so very important that you watch these 5 concept videos. Great. So proportionality theorems. But before we can do proportionality, we have to find similar triangles, right? Do you guys agree? Those of you who've done proportionality, we first have to find proportional similar triangles. So they want WR, they want RV, and they want RS. Where's WR? WR is here. Okay. RV is here. And RS is here. Do you guys see which triangles they might be talking about? Does anybody spot the triangles that they might be talking about that we could use? Does anybody see the triangle?
RVW and RWS.
RVW and RWS. Do you guys see that? Because aren't they similar? 30, 50, 100. 30, 50, 100. Do you guys see that?
Yeah.
Okay. So therefore the triangles are similar. Now, if they're similar, how do you find the relationships between the sides? And there's a concept video on this, and there's bank videos on this. So I'm going to go through it a bit faster. So basically, you just choose the different sides of the triangle. So you choose the big triangle. So it's going to be RV. You've got VW, okay, and you've got RW, okay. And then you just choose the sides in the other triangle which correspond to them. And the way you know that they correspond is that they're opposite the same angle. So RV is opposite which angle in the big triangle? Guys?
The 100 degrees.
It's opposite 100. And Uwais, okay, Ayan, what's opposite 100 in the small triangle? Ayan, what's opposite 100 in the small triangle? RW.
RW.
Right? What's WV opposite in the big triangle?
30.
30, right? And what's opposite 30 in the small triangle?
WS.
Okay, WS. What's RW opposite in the big triangle?
50.
Yes, and what's opposite 50 in the small triangle?
RS.
And basically, these are the proportions of the different sides. And because the triangles are similar, the proportions are equal. Okay. Now, in our question, there's no VW, no WS, so we can discard this. So we've got RV over RW equals RW over RS. What do we get? If we multiply out,
RW squared is equal to RV times RS.
okay. Is everybody clear on the approach? If it's not clear, it's fine, because there's lots of videos on this topic that we've made. Okay. Does anybody have any other questions on this section? Everybody fine?
Yeah.
Yeah.
Okay. So we do Kaylee's question now. Who has done analytical geometry? Has anybody done analytical geometry?
Yeah, me.
Okay. So that's the thing, you guys obviously are at different points in the syllabus. Some people start things first. Other people do things afterwards, which is totally fine. But the nice thing with Tutonic is that you're not actually behind, because you can actually learn everything. So you can you can learn whatever you want to. Okay, so it's not okay. This is just not unnecessary now what I'm doing here. But anyway, find the equations of the tangents. Okay, so in grade 12, you'll notice that there's only 2 concept videos on analytical geometry. If you look very carefully, you guys see there only 2, right? And if you know these 2 concept videos, you know the entire grade 12 analytical geometry. Okay, there's only 2 videos. And if you know these 2 videos, you know the entire grade 12 analytical geometry. But what I want you guys to realize, somebody's mic is a bit loud. What I want you guys to realize is that look at the grade 10 analytical geometry. Do you guys see how big that is? Do you guys see how big that is, guys?
It's a lot.
It's a lot, right? It's not a lot, but it's small concepts that are, there's a lot of small concepts. It's not difficult concepts, but there's a lot of small concepts. So I want all of you, before you even start with grade 12, guys, before you start with grade 12, just make sure you go through this and just tick it off in your brain and say, okay, I understand that, because you'll surprise yourself. You know, guys, sometimes I notice students aren't always taught everything in the syllabus, or maybe they weren't present when it was taught to them. So just make sure that you watch all of these, just to make sure, rather be safe than sorry. Okay, don't assume that you know it just because you're not in grade 10 anymore. Okay, so I want you guys to go over that when you have a chance. Okay, so now, Naima, since you've done circle geometry already, okay, can you tell me something about the circle? What can you tell me about the circle? Naima?
Yeah.
What can you tell me about the circle?
I don't know. There's many things.
Ilyaas, I think the center is at 2 and -3.
Yes. So there's 2 things that you can tell from the equation of the circle. What are the 2 things that you can tell from the equation?
The center and the radius.
The center and the radius. Okay, so this is a nice website that we use to plot graphs. It's called Desmos. This is basically the graph. So you guys can actually, you could have predicted this graph, because you could have said, as Hamza said, the center is at 2 and -3, and the radius is what? It's 4, right? Do you guys agree the radius is 4? Because isn't this r squared?
Yeah.
Okay. So
Yeah.
so do you see how just from the equation of the circle you have so much information? And that's why I always tell you guys that your equations have meaning. You know, they're not just numbers. Remember, maths is a language. So you have to think of your equations as a communication tool that is trying to explain something to you. So you have to ask yourself, what is this equation trying to tell me? It's trying to tell me that the center of the circle is at -2 and is at 2 and -3. It's trying to tell me that the radius is 4. Do you guys see that? So everything in maths, every equation in maths is trying to tell you something, and you have to understand the mechanics of the equation. That's why I say, like, you know, don't just memorize the equation, understand the equation. And there's a concept video on that. So they're saying, find the equation of the tangents that are parallel to the y-axis. So let's take out our nice, you know, parallel to the y-axis, okay? So if it's parallel to the y-axis, do you agree it's a vertical line? Right? Okay,
Yeah.
I think your mic is a bit loud. Yeah,
Oh,
that's
sorry.
fine now. No, it's okay. It's okay. It's just okay. So you guys see that it's a vertical line, right? Now they want the equation of that line. Now, if you draw the circle, it's kind of obvious to see what the equation is. Do you guys see that this is 6 and minus 2? Do you guys see that?
How do you know?
Because you can see there's 6 and minus 2. If you draw the graph, if you draw the circle.
Okay.
However, if you didn't draw the graph, you could say that the center is at 2 and minus 3. My question to you is, what can you tell me? Because somebody sent something to the chat. Oh, the app is called Desmos. Desmos. That's the name of the app. Okay. The radius is 4. Yeah. Okay, we know that. Okay. So what can you tell me about the radius of this the radius and this tangent? So the radius with respect to this tangent. Anybody? Naima?
Sorry, what did you ask?
The radius that I draw to meet this tangent, what can you tell me about that radius? What do you know about the radius and the tangent? What's the rule in circle geometry with the radius and the tangent?
Radius is perpendicular to the tangent.
Okay, so remember guys, I said that there are 3 tangent properties. I want you guys to memorize these 3, okay? So the radius is perpendicular to the tangent. Okay, perpendicular to the tangent. But if the tangent is a vertical line, what does that mean about the radius? What does that mean about the radius if the tangent is the vertical line? Guys, there's 11 of you. If the tangent is a vertical line and the radius is perpendicular, what does that mean about the radius?
It's a horizontal line.
It's a horizontal line. Okay, you guys will see that.
Yeah.
If
Ilyaas,
yes.
Why says please check the chat.
Oh, okay. Chat. You can use the radius to find the tangents. Yes, exactly. Yeah. Sorry, I wasn't looking at the chat. So basically what he's saying is that you know this point, right? 2 minus 3. And since this is a radius and the radius is a horizontal line, you can just add 4 to the radius. Add 4 to the x value to give you 6. Do you guys see that? Does everybody see that? Because this distance is 4. How do I know it's 4? Because the radius is 4. And it's a horizontal line. And the same thing on this side. If I extend on that side, what's this x value going to be?
-2.
-2, right? Okay. Now, given that you understand that, let's do the next question. If the tangent was parallel to the x-axis, what does that mean? What does that mean about the radius?
It's a vertical line.
The radius is a vertical line.
If the tangent is horizontal.
But the tangent is parallel to the x-axis. Therefore, anything that is anything that is parallel to the x-axis is a horizontal line, right? Everything that is parallel to the y-axis is a vertical line. So therefore, what can you do to find this y point over here?
Add 4 to the -3.
Which is
1.
1, right? And then the other one at the bottom,
I guess you're gonna -4,
which is
-7.
okay. So this equation's y equals 1. This is y equals -7. This one is x equals -2, and that one is x equals 6. Okay, and if you're not so sure about vertical and horizontal lines, this concept video will help you. So you guys see do you guys see how this question required you to understand horizontal and vertical lines? Do you guys agree? Do you guys agree? Horizontal and vertical lines.
Yeah.
Do you guys agree, guys?
Yeah.
Yeah.
Horizontal and vertical lines. But
Yeah.
which grade was that taught to you?
10.
10.
So do you guys see why it's important to go back?
Yeah.
You guys see that? I'm
Yeah.
not making this stuff up, man. I'm not just like saying I'm not just telling you to go back for the sake of going back. It's because when you want to answer these questions, they assume that you know these things. Okay? So that's the thing about matric. You have to basically know your grade 10 work, your grade 11 work. So Tutonic makes it easier for you because you can start here and then work your way up to grade 12. Okay? So I hope I've convinced you guys to go back to the previous grades when it comes to these types of questions. Okay. Let's do your one. Okay. Any questions so far? I mean, other than what I've already. Now, Uzair, you asked a nice question. Okay. When you tried this, what did you think about this question?
Oh, we did this one.
Did we do this one already?
No, I didn't.
Okay. Yes. Uzair?
It seemed simple, but there was that harmonic series maneuver that you spoke about.
Okay. How
Yeah.
do you understand the notation for sigma? Are you comfortable with the notation?
Yes, I'm comfortable, but
Okay, so what is the first term of this expression? How would you work that out?
I would sub 3 into y and then work it out. And
Yes,
then,
correct.
yeah.
Great. So I want to show you. So whatever I do when I look at these questions is that I really like to plot. Sorry, I mean I like to write out the series. So what's the first term of this when I sub in 3 into here? What's the first term? 1 over, which is just
1.
1 minus, what do we sub in here?
3.
And therefore,
So
what's it gonna 1 over?
would be a half.
A half. Okay. So that's the first term, right? Then what's the next number we sub in? 4, right?
Yeah,
When we sub in 4 into here, what happens?
we get a half.
Right? Minus.
A third.
Right. And then what's the next number we sub in?
5.
Right?
So
And that gives us
1 over 3 minus 1 over 4.
Can you predict the next one?
Yeah. So
What's it
1
gonna
over
be?
4 minus 1 over 5.
And you're adding these, right?
Yeah.
Now notice what happens. Can't this cancel? Can't this cancel?
Yeah.
Can this cancel?
Okay.
So it's going to continue all the way until you get 1 over 8 minus 1 over 9. Because it's going to be 1 over 7 minus 1 over 8. And that's going to cancel. And you're going to be left with 1 over 9. Why? Because what's the last number you sub in? You sub in 10, right? You guys agree? The last number you sub in 10. So what's 1 over 10 minus 2?
1 over 8.
And then it's 1 minus 1 over 9.
Mm-hmm.
So then that means that all of these are going to cancel. And you're just going to be left with 1 over 9. So it's going to be 1 minus 1 over 9, which equals?
8 over 9.
Okay. So Uday, do you see how all we did here is that we just expanded it?
Mm.
And the way we now to expand it is because we understand the concept. Okay. So do you see how all we did here, we just subbed it in. You see, and I think this highlights a very important lesson that I want you guys to realize, that in mathematics, the question may seem difficult, but often the case, it's just, if you understand the question, then the solution is really easy. And I think what I've noticed is that sometimes looking at a question like this looks so daunting, right? This looks horrible. Do you guys agree? This looks horrible, right? It looks horrible. But that's why we write it out. And it doesn't look so horrible. Okay? So that's my advice. Okay? Is everybody happy with that one?
Yeah.
Okay. Okay, Amara, we do your question. Okay, what did you, you've asked a lot of optimization questions. What did you think about this one when you tried this one? Amara?
Okay, so I tried.
I think the mic is off.
I tried it, but I wasn't sure. So.
But what did you try? How did you start with the question?
Okay, so first I labeled it. That's how you do it. So they said that it's an equilateral triangle with side equal to a units. So therefore, all because they said it's equilateral, so all three sides are the same or equal. So AB is A, AC is A, and BC is also A.
100%.
And then they said that BE is equal to X and FC is equal to X.
Mm-hmm.
And then, yeah, so.
What else do you know about equilateral triangles?
Well, angle is 60 degrees.
Angles.
All the angles are 60.
Yeah.
Okay. So when they say equilateral triangle, in your mind, you must think two things. You think equal sides and equal angles. And the only way you can have equal angles in a triangle is if they're all 60. Okay. DEFG is a rectangle. So, okay. So with 10.1, what did you think when you saw 10.1?
So the area of a rectangle, so.
Great. So you're starting with the area of the rectangle, right? What is the area of the rectangle?
Length times breadth.
Okay, so Amara, what's the length of the rectangle? How could you express the length? Do you have any ideas?
Isn't it a minus 2x? No.
It is. Why do you say no?
Oh, never mind. Okay.
Amara, do you see why it's a minus 2x?
Yes.
Because it's just, this is x, that's x. So this is just going to be a, which is everything, minus those two x's. Do you agree?
Yes.
So you've got the a minus 2x part done. But the breadth, okay, what about the breadth? What's the breadth? Any ideas, Amara?
No, I'm not sure.
Anybody want to help her? Hamza, you want to help her?
I'm not sure.
Anybody? Kai? Naima, do you have any idea?
No.
Going once?
Ayan is Pythagoras. No, you can't use Pythagoras because we don't have the sides.
You getting warmer? You getting warmer?
We have one side and one angle. We have a side and an angle. Is there a rule that
Can we use the sine rules? No.
You can say
Why
10
sine?
60.
10.
10 60 is equal to breadth over x.
You guys are neglecting the simplest trigonometry rule that you were taught. When you have a 90-degree
Oh.
triangle and you've got an angle and you want that. Do you agree you want this side, right? You want this side, GF.
So use 10.
So tan 60 equals what?
GF over X.
Or we can say y, so over x. Sorry, over x. What is tan 60?
Root 3.
And how did you know that? Okay, you maybe memorized it, but you guys can always draw the special triangle 30, 60, 90, and you know sine 30 is a half. Okay, so therefore tan of 60 is just root 3. Okay, so therefore, if you're solving for this, which is the side, you guys see why it's root 3 times x.
Yeah.
Yeah.
Does it make sense?
Yeah.
Yes.
Okay.
Yeah.
So again, in this section, it would have been in the mind map under trigonometry in grade 10, using trig ratios to calculate the length of an unknown side. You guys see that? That's what we did to answer this question. Do you guys see? Guys, you see that?
Yeah.
But this is grade 10. So that's why I'm saying, if you go back, just to make sure that you build that foundation, make it strong, because in grade 12, you can be asked things from previous grades, okay? So I'm always just trying to emphasize this point over and over again, because that's how much I believe in understanding those concepts, okay? It might be a bit excessive, but I hope you understand like why I do it. Amaro, does it make sense now?
Yes, yes, it does.
Okay.
This topic, optimization, or
You could say, you see, this is a bit of a mixture because there's a bit of trig also, but
okay.
because they want maximum and stuff, I would classify it as optimization.
Okay.
Yeah. But you guys must not think that because it's calculus, they can't ask you trig in it. Just like you mustn't think if they ask you number patterns, they can't be calculus in number patterns. So that's why you mustn't think of it in isolation. So you must realize that sometimes you can take concepts from one section and mix it with the other section. It doesn't happen often, but you don't forget all the number patterns when you're doing trigonometry. You get what I'm saying, right?
Yeah.
You need to bring it together, okay? The maximum area, what do you think, Amaro?
Oh, so we find the area of the rectangle, right? So find the maximum. Can't we find the derivative equal to 0?
There we go. But then yeah. So to find the derivative of this, is this going to be enough? Or are we going to, are we gonna? Would it be better to do something else first? What would you want to do to this equation if you wanted to take the derivative?
It.
Yeah, simplify it. So what could we do? Multiply out, right? So
yeah,
root 3a x, or a times root 3x, whatever. Yeah, let me just make it easier for ourselves. A times root 3x minus 2 root 3 x squared. That's the equation for the triangle. What is the derivative? Who wants to do the derivative for me? Sabiha, can you do the derivative for me?
AX.
AX.
Oh, no, sorry.
But first, what's the derivative operation? So like, you're not like in your exam, you're not just going to write equals AX, right? What are you going to write?
dm over dx.
dm over dx. Guys, don't forget that, guys, because the marker wants to know that this person's finding the derivative, right? So it's going to be dm over dx equals a root 3. You said right? A is a constant. It's a constant. Okay, so a root x. Okay, and what's this gonna be?
4 root 3x.
What's next?
Set it equal to 0.
Right. And who's going to help me solve this?
Take the minus 4 root 3x over.
Right, so we could say root 3a equals 4 root 3x. We can divide out by the
4 root. Oh.
4 root 3.
Yeah, by root 3.
Sorry, what am I doing there? Sorry. Divide by the root 3, right? Or the 4 root 3, right? Whatever, right? So we can divide out by the root 3. So we're left with 4x equals a. So therefore x equals?
A over 4.
A over 4.
In terms of a.
What does in terms of a mean? What did we say, guys?
Subject.
No. So remember, when you say in terms, it means
A must be
that,
the subject.
No, not a.
Oh no,
If
it
I
must
say,
be in the equation.
It must be in the equation, right? So you're solving for x, and then a is in the equation, okay? If they said in terms of x, then it's going to be a equals 4x, because you're solving for x. So solving for x, okay? But is this the area? Is this the maximum area, Amara?
No.
How do we find the maximum area? How do we find the maximum area?
You sub it back
Would
into
be
the
we
original
don't
observation.
this its value into the original equation.
Yeah, so we could sub it in, so it becomes √3 times a over 4 multiplied by a minus 2a over 4, which is a half a. What's a minus a over 2?
Isn't
What's
it
a
like
minus?
a over 2?
It's just a over 2. It's just a over 2, yeah. It's just a over 2. Because it's like 1, what's 1 minus half?
A half.
So, let's go. So, and then what's this going to become? Let me multiply out.
√3a squared over 8.
There we go. You guys will see that.
Yes.
So do you see how it's the same approach?
What
You
do they
just
mean
have
by
to
maximum area?
Okay. Have you covered calculus yet, Kai, in
Not
class?
at all.
Okay, that's okay. So basically, the maximum area is something that we work out in calculus, where we put the derivative equal to naught. Because what we need to understand is, if we draw a graph, if I draw this graph for you, what type of graph is this, Kai?
Parabola.
It's a parabola. Do you agree that a parabola has a maximum
Yeah, it
point?
does.
Okay. So this graph over here is actually a parabola. Do you agree? Because it's
Yeah.
minus squared. So it's going to be some type of parabola. So that parabola is going to have a maximum point.
Okay.
So in calculus, what we do is that we make the derivative equal to naught. And I don't expect you to understand all of this now because you haven't done calculus yet. But what I would suggest is you go watch our calculus concept videos. Okay. If you want to get ahead, okay. And it will all make sense. Ask Naima. Naima, can you maybe give some guiding words for Kai here? Because you didn't understand calculus when, yeah, just Naima, do you want to just say your experience?
I don't know what to say.
Because like I had done calculus on my own, right? The only
Yeah,
part that I could never understand was the maximum value. Because I saw they always ask about maximum, and yeah, that just.
Okay, I was just basically, so Naima, you didn't know calculus before you joined Tutonic, right?
Yeah.
Yeah, so your first time doing calculus was in one of these live sessions.
Yep.
Yeah,
Right.
but now you feel a lot more confident. So I don't want these concept videos are a very powerful way to help you understand the different concepts. So your question, Kai, was what do you want to understand the maximum thing?
Yeah, the maximum thing.
So do you understand the derivative being equal to naught? What that means?
Okay, yeah.
What do you understand by the derivative being equal to naught?
You know what I do? You just said that if they're doing the maximum thing, you should put the derivative equals to naught. So I don't necessarily learn why we do it. I just memorize that we should do that, and then.
Okay. So the
I don't know why.
The concept video will explain to you why. Okay.
Okay.
So that's why I want you to watch the concept video. But I can explain to you now as well. But the concept video obviously goes into a lot more detail. But basically, the derivative is the derivative not the gradient?
Yes, it is.
it's basically exactly the same thing. Do you know that rule which says the gradient of the tangent is the same as the gradient of the graph at the point of contact? Have you come across that rule?
Yeah.
So the gradient of the tangent is the same as the gradient of the graph. So do you agree that at the turning point of a function, the gradient is a horizontal line?
Yes.
The tangent is a horizontal line, right?
Mm-hmm.
And what is the gradient of a tangent? So what's the gradient of a horizontal line?
Isn't it? It's the okay. I know there's one which is undefined, and the 0 one. I never really learned them.
Okay. Anybody want to help her? What's the gradient of a horizontal line?
0.
It's 0.
Oh, so that's why we make it equal to 0.
You make it equal to 0 because at that point, the gradient of the graph is equal to the gradient of the tangent. But the gradient of the tangent is the gradient of a horizontal line, and the gradient of the horizontal line is not. Okay. So, but this is all in the concept videos. I'm just explaining to you. Yeah. So that's why we make it equal to 0, because at this point, when the gradient is equal to 0, that's at the turning point.
Okay.
Right? But now the turning point doesn't always have to be a maximum. It could be a minimum if the graph was like this. But because this was a negative cubic parabola, you could assume that the turning point was a maximum. Okay. Great. Okay. But go through those concept videos to flesh out the understanding. Okay. Let's go to the next question. I think that was, one more, sorry. This is also a calculus question that Two asked. Okay. He's not in the session, so I'm not sure which one he wants to do, but we can do all. It will be a refresher for many of you. Okay.
Okay.
Has anybody here not done calculus? No, I think you all have. Besides Kai.
No, we haven't. Yeah.
Who hasn't done it? Besides Kai. Oh, you all okay, okay. So okay. So this should go a little bit faster. Okay. Determine the derivative of 2x squared plus 4 from first principles. 2x squared plus 4 from first principles. Does anybody want to give it a go?
You substitute x plus h wherever there's x in the equation.
Right. So do you want to do that for me?
Okay, so 2 into x plus h squared plus 4.
Are you saying this?
Yes. No.
Oh,
Outside.
You see, just be careful. Just be careful. I'm gonna trick you. You see that you have to be. They are gonna be trick questions. They always say there's no trick question. I am gonna try and trick you because I want you to be strong. You see, because you have to be strong. So some people might say h squared, but it's actually outside the bracket. How do we know that? Do you guys know how to do this? Or do you want me to show you what I do?
There's a shorter way, isn't there?
What's
of
the shorter way?
expanding. You square the first term, square the last term, then you multiply the 2 times 2.
No. How did you know like that this must be 2 open bracket x plus h squared? If they said x plus h.
Oh, that's how it should be.
Yeah, but how do you know? Okay, so what I do is if you have 2x squared, I put a bracket around the x's and I erase the x and then I insert whatever's there. So in that way, it protects me from not making stupid mistakes, like saying h squared or x squared. Do you guys see that? So that's a very nice technique that I've used. Okay, so what's next, Naima?
Now expand the bracket. So it will be 2x, oh wait, sorry, it will be x squared plus 2xh plus h squared.
Times 2,
You
right?
just want
So
to
it's
find the
going to
answer
be,
with the, yeah.
yeah, so we can just do it one time, and then it's 2h squared plus 4, okay, which is equal, okay, yeah, so that's that. And then what do you do next?
You write down the equation form, f into x plus h plus fh over h.
Plus f of x.
Minus.
Oh no, sorry, minus.
Okay, so I actually prefer, before we do this equation, to actually first subtract them, because I don't like writing all of this stuff here, like it's too much. So I first say, after I do this step, I say f of x plus h minus f of x. And what is that equal to?
4x plus 2h squared.
These will cancel, right? You guys see that? Those will cancel. So you're left with 4x8 plus 2h squared. And that must be over h, right? Over h. So what are we left with? How can we quickly divide out?
4x plus 2h.
You take out h as a common factor.
Yeah, or yeah, I mean, so, but if you have one term in the denominator, you can just divide out. Okay?
Yeah.
Plus 2h. Okay? So do you guys see we've simplified this whole thing here? Like this is just that. So do you guys see it's much easier now to just sub that into here? Do you guys see that?
Yes.
Okay.
Yeah.
So now I'll say the derivative is equal to the limit of 4x plus h, 2h, as h goes to 0. And what is that equal to?
4x.
4x.
Because as h goes to 0, this term goes to 0, which means you're just left with 4x. And this makes sense, right? Because 2x squared plus 4, if you use the quick rule, it becomes 4x, right? Do you guys know who invented calculus?
Isaac Newton.
Right. You know how old he was when he invented it? He was 21 when he invented
was
calculus.
bored of his life.
And he invented it in the same amount of time that we learn it. You know, so I think one of the things that we don't do enough in maths is that we don't learn about the people that discovered the stuff. And I think once you realize the type of people that they were, you start to appreciate the maths more. And you start to give it more respect. Because like my teacher once said to me, and I'm not saying you guys are like this, I'm just saying in general. He said to me, because I think we were being naughty once, and not me, but okay, but he was saying, you don't have to respect me. So this is the teacher speaking, saying, you don't have to respect me, but at least respect the knowledge. You see, at least respect the knowledge. And I think that's the mentality that we have to have with maths, is that you guys are learning in most cases in 1 week what it took mathematicians maybe 500 years to discover. So that's a privilege, you see. That's a privilege. So we need to not take these things lightly. We need to realize that we are gifted by learning from other people. And you know, Isaac Newton's famous quote, when people asked him, how come you achieve so much in your life? And he said to them, that if I have seen further, have you heard this quote? Anybody heard this quote? Anybody hear this quote? He said, if I have seen further, if I have gone further, it's because I've stood on the shoulders of giants.
Beautiful.
If I've gone further, it's by standing on the shoulders of giants. So that's why the first step of being a student is to recognize who the giants are. How can you stand on the shoulders of the giants if you don't know the giants? You see? And this is something that I think our syllabus needs to work on. Anyway, that's a tangent, not this tangent, actual tangent. But so let's do the derivative. It's not really written very nicely. Minus 3x squared plus 5 root x, the derivative. How do you guys approach this? Who wants to go? I mean, who wants to give it a go? Nafisa, do you want to give it a go?
Okay, so first I would take out the third by putting it to the exponent of a half.
Okay.
X to the power of a half.
So you're not finding the derivative first. You're first making it look nice, right? Make it look nice.
Yes.
Get it ready. Prepare it. Prepare the food before you eat it. Okay, yeah. All right. So what's next? Who wants to do the derivative? Nafisa, you want to do the derivative?
Negative 6x plus plus 5 over 2x. Yeah, then x.
To the 1 or what's the exponent going to be?
Negative a half.
Yeah, negative half.
Negative half, okay? Because we're subtracting 1, okay? And so we just multiply by the base and we multiply by the exponent and we subtract by 1, okay? So then the next one, I can't even read that. 1 over x cubed plus, okay, 1 over x cubed plus 4x all raised to the power of 3. Is it 2 or 3?
Or 2.
Like a 2.
It looks like
It's a 2, yeah.
let's make it 2. It's easier if it's 2. Okay.
Go to.
Okay. So what are we gonna do? Zay, you want to give it a go?
The FOIL method.
Yeah. So how do you do the FOIL method first? What are you gonna do?
It's gonna be that bracket, just another one next to it.
Right. Okay. So 1 over x cubed. Okay. Right. So.
FOIL it.
So it becomes.
Oh. Can we write the 1 over x to the 3? Can we write as x to the minus 3? Just looks better.
Yeah, sure. We can write it as x to the minus 3, sure, just to make it easier. We're all going to end up doing that in any case. Right. X to the minus 3. X to the minus 3, okay.
And then that will be x to the minus 6.
Right. Great.
Plus 4x to the minus 2.
Right.
Plus 4x to the minus 2.
Which just becomes 8, right? It's.
And then plus 16x squared.
Great. 100%. Okay. So now we've just simplified it, right? So what's the next step? So that's y equals that. Okay. wants to help with the derivative?
Do the derivative.
Okay.
Negative 6x to the power of negative 7.
Mm.
And negative 16x to the power of negative 3.
Right.
And plus 32 to the, and just f.
Yeah. Okay. So you guys have done it. So those are the first two questions. Okay. Let's go to the next one. It's a graph. Okay. What type of graph is this?
Cubic function.
Great. Okay. You can see that without the equation and with the equation. Because if you had the equation, you would see a cubic. Okay. But if you didn't, you would also see it's a cubic graph. The x-coordinate of A is at 1, right? So they see that there. This is at 1. And C is another x-intercept. Great. What's the derivative of this one? Who wants to do the derivative? Kai, you want to do the derivative?
Okay, I'll try.
It's difficult to see. X squared minus 7x squared plus 14x minus 8. Okay.
So it's 3 times x to the power of 2.
Right. So we're gonna say h prime x. Okay, right? Because that's one of the notations for
have to do
derivative.
that.
Yes, because if you just write the derivative, they don't know this is the derivative.
Okay.
So you need to tell them I'm doing the derivative. Yeah. Okay. So yeah, 3x squared. Right. Next.
Okay, wait. Okay. When do we, can I just ask a question? When do we do that thing of dy over dx?
That's if they give you an equation y with something with x.
Oh,
Right.
okay.
Then you can say dy by dx. But if they give you like f of x equals 4x squared, then the derivative will be f prime x.
Okay.
You see the difference?
Yeah.
So here they're giving you h of x. Do you see that?
Yeah.
So they're using h prime x. So it's a good question. It's just different notation. Why? I don't know really why they have different notation. I mean, it's not really, I mean, yeah, it's like
Okay, and then it's
300
minus
pound. Yeah, minus.
minus 14x
Mm,
plus 14 and
right.
then x to the power of 0, which is going to be 1.
Yeah. So it's plus 14. Right?
Minus 0.
Yeah, so it's just going to be 3x squared minus 4x plus 14. Do you agree?
Yeah.
Yeah.
Great. Okay. The x coordinate of the turning point B. Anybody want to give it a go?
The derivative equal to 0.
Right. So where's the derivative?
We just found it. Top
Yeah.
right.
so we put that equal to 0. Yeah. Do we know one of the answers already? No, we don't actually know them. Sorry. Can we factorize
No,
this?
No, we can't. Let's use the
no.
Can't we? Definitely.
Oh, isn't it
Yeah,
easier to
no,
just use the formula?
Get the decimal.
yeah, we get a decimal answer. So what are the two answers you get?
1,45. and
3,22.
2.
Okay. So everybody understand what we've just done here? We've put the derivative equal to naught. Why? Because we want to find the turning point. Okay, Kai, does it make sense? You're wanting to find the turning point. The turning point in this case is the minimum. Do you see that, Kai?
Yeah.
Okay, and there's the maximum. But in this question, you got two answers, right? So you can't say which one's the minimum or the maximum yet. You have to sub in and see, okay? Because you don't know, you get two answers. The coordinates of C, Naima?
It's the x-intercept, so
What do we do to find the x-intercept?
make y equal to 0.
Right, so it's naught equals x cubed. And now Nafisa, is Nafisa here? Nafisa, you got to do synthetic division for this one?
Yes, I'm gonna do it now quickly.
Okay.
I actually like it, the synthetic division.
So much
Yeah,
easier.
she's converting people here.
It's a good thing. Wait, what's the factor?
Okay. So what we're doing is we're
No,
trying
we
to solve.
find
You actually know one factor already.
it.
They give it to you in the question.
I got to.
The x coordinate is 1 at A.
1?
The x coordinates of A is 1. So they already have a factor. You guys see that?
So isn't it they tell you that the x coordinate is 1, that's your root, but then the factor will be -1, x -1.
Yes, so I'm saying you don't have to find the factor, you already have it.
Oh, okay.
You already have the factor.
Okay.
Okay. And Kai, have you done something like this before, solving cubic equations?
No, that I can't get. It's so hard. I won't lie. I don't even know how to do it.
Okay, here's a concept video, how to find the x-intercept of a cubic function, okay? So I want you to watch that video. And in that video, we actually changed the video because of Nafisa, because Nafisa showed us a, a different way. So in this video, I explain both methods. So you can actually choose the one that makes most sense to you, okay? So, but I promise you, Nafisa, you're doing it like, once you know how to do it, it's easy, right?
It is.
Yeah.
Right? So, but it's just practice, right? So just practice. Once you know the concept, you just have to keep on practicing. Okay. So I'm going to do it my way because I feel like it's faster, but you guys can do it the synthetic way. Okay. +6 +8. Okay, x minus 1, x plus 4, x minus 2, x minus 4. You get that, Nafisa?
Yes.
So therefore it's 1, 2, and 4. Okay. And for those of you watching this video, all I did, I applied the concept video on finding the x-intercept of a cubic function. Okay. So this is all explained. So there's nothing new here. There's nothing new. It's all stuff that we've covered in previous live sessions and in concept videos and bank videos, okay? The graph of H is concave down when X is below K. Now calculate the value of K. What does it mean when something's concave down? Does anybody want to explain?
Isn't it f of x is less than 0?
F of X?
The second derivative is less than 0.
The second derivative is less than 0.
Oh.
Okay, the second derivative is less than 0. F of X is less than 0. It just means y is below naught. So therefore, that's okay. Okay. So let us find the second derivative. What's the second derivative, Hamza?
It will be 6x minus 14.
6x minus 14 equals?
0.
No. Must be less than naught.
Oh,
Yeah.
So there's the trick. There's the trick.
Equations.
Okay. Yeah, there's the trick. Okay. Because some of you also, you find second derivative, you want to put it equal to naught. If you put it equal to naught, what would you be finding, by the way? If you put it equal to naught, what would you be finding?
Point of inflection.
Right. And the point of inflection would be like here, right? Somewhere here.
Yes.
Okay, so here's the tangents, 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 and then they flip over from the top to the bottom here. So graphically, we could even work it out, right? So what is the graphical meaning of concave down? We know the algebraic meaning is the second derivative is less than naught, right?
Where the graph
What's
is
the
below the tangent. So
graph is below tangent. Where's the graph below the tangent?
At point B.
yeah. 1 and 2 B. Yeah.
No, from here
Yes.
to the left. To the left of the point of inflection. Do you
Yeah.
see that? So
Yes.
not from B, from here. Okay. So that's graphically. Let's see algebraically if it works, right? So we're saying, okay, 6x minus 4 is smaller than 0. So therefore 6x is smaller than 14. Therefore x must be smaller than?
Divide by 7/3.
And I think 7/3 is probably over here. This is the point of inflection. And we're saying it must be smaller. And that makes sense, right? So that's what we've shown graphically. It must be smaller.
Yeah.
And so be careful. This is not the answer because they're asking k. So therefore k equals 7/3. Do you see that?
Oh, okay.
X must be smaller than k. So what's k?
Okay.
Okay. Okay, so what is any other questions?
I have, but I'm kind of running out of time, so I'll just send it on the question stuff.
You can send it now. What type of question is it?
It's a it's calculus, but it's a 2-mark question, so
Okay, there was 2 marks, and I'm sure is it a difficult one?
I
Mostly I
don't
won't.
understand it. I think.
Okay, you can send it. We have 4 minutes. I think I've seen this question before. Let me just have a look at it. This looks very familiar to me. I don't think it's on the bank, but I've seen it very similar. Was this 2014 or 2016? Naima?
2016.
Yes, I remember this because this
2016.
was okay. Yeah. So John determines the derivative of a, the derivative of a certain function at x equals a, and he arrives at that. Okay. So yeah. 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 So this is the derivative, the limit of root 4 plus h minus 2 over h as h goes to 0. Okay.
Yeah.
Right.
Yes.
So I think you could also solve this by trial and error, because basically, do you agree that the top, the numerator is just the root fx, if, like, do you agree that f of x equals 2? F of a is 2. Because isn't this f of x? Right?
Yes.
This is f of x plus h. Do you agree? So therefore f of x,
Yeah.
when x is a, is 2. Right? Do you agree? And f of
Yep.
x plus a, sorry, f of a plus h, right, is root 4 plus h. Now, what type of function do you think we're dealing with here? Naima? Hamza, what type of function do you think we're
Yes.
dealing with here?
A quadratic function.
Not quadratic.
Oh, that was the case.
It's a square root equation. It's a root equation because of this. Do you see that?
Exponential.
No, not exponent. The root. It's a square root function. So
Oh.
the function is going to have something with a square root. That's what I'm trying to say. You guys agree?
Yeah.
It's going to have something with a square root. And what's the simplest square root function? Root x. Right?
Yeah.
If I sub in, what must I sub into root x to give me a, to give me 2? So what value of x must I choose to give me a y value of 2?
4.
4. I hope you can start seeing it. But so if I sub in, so if it's root x, then f of 4 will be 2, right? And therefore f of 4 plus h is going to be what?
Oh. No.
4 plus h. Yeah. Under the root.
Therefore this must be the function.
Maaf, Ilyaas, could you just explain where you got that 2 from?
We have got the 2. Which
Yes.
2? Which 2?
By f
Yeah.
of a equals 2.
Because, do you agree that the numerator of a first principles is f of x plus h minus f of x?
Yes.
Therefore, f of x must equal 2.
Okay, I see.
But they subbing in a for 2, for x. Do you see that?
Oh, okay. Yes, sure.
So if we were to take the function root x and I subbed in, firstly, if I use first principles, right, it would be what? It would be the derivative of x is equal to the limit of root x plus h minus root of x over h. Do you agree with that, Naima?
Yes, I do.
So what happens when I sub in x is 4?
You just get 4 plus h minus 2.
Get the original one.
Which is that. Hmm.
Yeah.
So therefore that works. So therefore the function, the equation must be y equals root x and a must be 4. But this is a higher order question. It's not your standard question. But does it make a bit more, does it make sense?
Yeah, it does.
It's not, I mean, this is not the question that you'll get all the time. This is a higher order question, but I'm pretty sure there's a way to do it without trial and error. But I just remember because in 2016, I was helping some matrics, and I remember they came to me with this question, and it was not an easy one, but luckily it's only 2 marks, right? So they will never give you like so many questions that are impossible. I hope I've shown you that the majority of the questions, like the majority of the questions we've done on Tutonic, like 95% of them, it's all the concepts that we've done. Do you guys see that? Like, I hope I've convinced you that like 95% of all the. Do you guys agree, Hamza, Zair?
Yeah, definitely.
Nafisa? It's all stuff that you have been taught. It's just you guys need to revise them. So like with functions, go over this stuff, go grade 11, go over these things, and the nice thing is that you can do it in your own time, right? Nobody's telling you that you have to watch it now. So with Tutonic, you can watch it at night, wherever you can watch it in the morning. That's why we created it like this, so that you have everything that you need, It's just that you have to watch it. That's the only catch, is that you have to watch it. I think last week I said to you guys that we want to help you, but you need to help us help you. And the way you can help us help you is by following that algorithm that I showed you guys at the beginning. Yeah. Okay, so that algorithm that I showed you guys, if you guys stick to that and hold on to that, you will all succeed. I guarantee you. If you just hold on to that, no, you'll get more, hopefully. If you just hold on to this approach, I promise you, you see, the problem is where do most students go wrong? Most students go wrong is because they want to start here. That's what I've picked up. They want to start here. But the problem is that these things, these questions depend on this. And I hope I've shown you guys that. You guys admit that they all depend on this. So it doesn't matter how many times you do this. Right, guys? It doesn't matter how many times you do this. This has to be strong first. Okay, and that's why I put the questions as number 3 in the algorithm. You have to start here. Okay, and yeah, that's kind of, I believe if you follow that approach, then all of you will succeed. Any other questions? Kyle, you happy? Nafisa? How was your
I'm
first
fine.
session? Do you enjoy it?
Yeah, you were really good.
They've got good questions. That's why. Yeah, so I think just keep on following this approach. And I'll see you guys next week. And hopefully you guys are going back on Monday, right?
Yeah.
So they say.
Have they spoken to you about it?
Not really.
Not my school.
Not yet. They haven't
Not
said anything
mine.
to you.
Nothing.
Yeah.
Apparently
And
they're
it's still...
supposed to send an email today.
Oh, okay.
I'm not sure if it came.
I would have thought they would have communicated by now if they going to have class.
But like honestly, with a
We've been
voice tool, it's not gonna work.
You guys too many.
It seems very impractical the way they plan to do this.
No
But how are they
breaks.
going to change it? How are they going to change it compared to before?
Our school's saying they're gonna have to split the classes and stuff. That's it.
They say 10 people per classroom. And
But you have enough teachers to cope to cater for that.
Yeah, that's the problem.
Because who's got to watch?
Yeah.
You need
But
more
look,
teachers.
If it's only the matrics, then you don't have to worry about all the other classes to supervise. So
Is it only the matrics who are going back? I thought the others are also going back.
no, grade 12 and grade 7.
Oh, okay. Okay,
Yeah,
that
but
makes more
for
sense.
Islamia, we have the grade 7s in high school already, so our grade 7s aren't coming back. I think they're coming back like 2 weeks later.
Oh, they're part of the high school. I see what you mean. Okay. Okay.
And if worst case, we can ask Mr. Galan to organize Ilyaas for us.
There's no need to organize. I'm always always here. It's like you don't even have to leave your house. Uzay make that joke. Yeah, why do you need school? But the thing is, what I recommend, I always told you guys this, that whatever section you do in school, let's say you do geometry in school, my advice to you is watch the concept videos on geometry before you go to class. You will realize how much of a difference it makes. Because then when you go to class, you basically know everything. And then your class time becomes, you close your gaps in class. It's revision. You close your gaps. And then when you go home, now you know pretty much everything. And then you can start with number 3. You guys see that?
Yeah.
But the problem is most people, when they go to school, they don't go to school with a foundation. So when they go to school, this doesn't make sense. The concept doesn't make sense. Then the teacher gives them homework. So then they start doing the questions. But because they don't have this, the questions become very difficult. And then it's a repeating cycle. So Tutonic wants you to break the cycle by going to class with some foundation from the videos. You close the gaps in class by the teacher and by the quiz, okay? And then when you go home, you can practice because you know everything, right? So there's no need to learn anything new. If you know everything now, you're just applying. But you can't apply and learn at the same time. That's the problem. That's why I say in your exams, you'll be tested on application. But before you can apply concepts, you first have to understand them. You can't apply what you don't know. That's the reality. You can't apply what you don't know. But Ilyaas, how do you know what you don't know? Well, you know what you don't know by doing the quiz. That's why we put the quiz at number 2, because the quiz will tell you, listen, you might think you know the concept videos, but hey, there's actually a section that maybe you need to revise. And that's why I put here, if you do not obtain full marks, then revisit the concept videos to close your gaps and then take the quiz again. so that for each section you only take the quiz once you only start the questions once you've got full marks. Okay. Therefore, before you start practicing questions, it's imperative that you go back to the concept videos. And that for me is the approach, because in that way you will never ever feel like you're behind. You're always ahead of your class. And when you're doing the maths, you actually feel like you're benefiting. A lot of people do maths and they feel like they're wasting time. And, you know, that's not what it's supposed to be. You know, each time you do maths, you should be able to take something from it and learn from it and improve and feel like you're adding something to your knowledge base. But you can only add to a foundation if you have a foundation. And that's what I don't think we encourage enough. We don't encourage that foundation. Otherwise, we would know the grade 10 work by now.
Yeah.
You see.
Can you see?
You see, so so that's why it's so important that you go back to the previous knowledge. And it's not like it's going to, because you've seen this before, it's just refreshment, right? It's just refreshment. And maybe there's new stuff that you haven't seen before, but that's how you learn, okay? And then you just keep on building and you're building and you're building and you're building until you get to the grade 12 work. Okay. Anyway, I will see you guys next week. And yeah, enjoy the rest of the week. Don't do anything problematic. Not like you can do anything problematic. But yeah, I'll see you guys. Thanks.
Bye.
Salam.
Bye.
Salam. See you, Kai.
Hi.
Bye.